Okay, so question 6. What is the electron configuration for the cobalt 2+ ion? So when we have ions which either have removed electrons or has like to an atom or added electrons to an atom, then it has a charge. So when you have a plus charge, that means you removed electrons, and if you have a negative charge, that means you added electrons. So in the case of the cobalt, when it has a 2+ charge, that means that we removed 2 electrons from a cobalt atom. So when we write the electron configuration of an ion, I first like to find out what the electron configuration is for just a neutral cobalt atom in its ground state, basically. So let's just find the electron configuration of cobalt in its ground state first. So you can find cobalt here, atomic number 27. So starting from hydrogen, we're going to move left to right, writing the row number and then the block letter. So we have 1s2, and the superscript tells us how many electrons are in that subshell. So we have 1s2, and then onto the next row, 2s2, then moving across the periodic table to the 2p, and then if you count it out, and you have 2p6, and then down to 3s, we write 3s2, and then 3p6, and then typically I like to sometimes write my my D block before my S block if it's around like the end, just to show that the electrons that are in the half-filled orbitals are more stable than if we had a filled 4s orbital. So I'm just going to write my 3d orbital first. And then from here, I'm going to count up to my cobalt. So if we count, we have 1, 2, 3, 4, 5, 6, 7. So I'm going to write 3d7. And then I'm going to write 4s2. Since the 4s orbital would be higher in energy than the 3d orbital. Okay, so we're left with this electron configuration for the cobalt in its ground state. If we were to write the cobalt 2+ ion, that means 2 of the electrons are removed. So we remove the 2 electrons that are in our s orbital. So now its electron configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d7. And if we were to write the shorthand configuration of this, then you just need to find the noble gas that comes before cobalt, which would be argon, and you write it in square brackets, and then you just continue on writing the rest of your electron configuration. So in this case, it's just 3d7. Okay, so now let's see what the junior tutor said. A noble gas configuration of an atom consists of the elemental symbol of the last noble gas prior to that atom, followed by the configuration of the remaining electrons. Elements that are found in the last column of the periodic table are an important group of elements that are called noble gases. For example, sodium, which is element number 11. So they have an example of its electron configuration: 1s2, 2s2, 2p6, 3s1, wherein the first 10 electrons of the sodium atom are in the inner shell electrons, and the configuration of those 10 is exactly the same as the electron configuration of the element neon. This provides the basis for a shorthand notation for electron configurations, which is the noble gas configuration. For cobalt, a chemical element with an atomic number 27, it has a complete electron configuration of the following. This is the same as what I wrote as well. Hence, when we use the noble gas configuration principle, it can be shortened to argon 3d7 4s2. So when we have cobalt 2+, it loses 2 electrons and becomes the cobaltuous ion. And they got argon 3d7. So this solution is correct.